Hello. I'd like to go over the sample two-dimensional projectile problem that is on page 20 of your distance learning packet. This was going to be helpful, I hope, for those of you that either couldn't be in class when we looked at it the first time or would like a second look at the process of solving these so-called projectile problems. When we read the problem, a football is thrown at 12.5 meters per second and released at an angle of 40.5 degrees. As always, I think it's useful to draw a picture. So here we have the football being thrown. You can draw a football if you want, not really necessary. We have the ground, and it is thrown at a velocity of 12.5 meters per second. So I'm going to label that vector. And we also know that that ball is released at an angle of 40.5 degrees. So this angle in here is 40.5 degrees. Now, I think we all have been around the world long enough to know that this ball will go up and it'll come down and it'll travel in a parabola. But let's cut to the chase. Gravity doesn't act at a 40.5 degree angle. Gravity acts vertically only. Furthermore, gravity doesn't act sideways. And so this velocity that's at an angle can be thought of as part horizontal, part vertical. In fact, you have to think of it as part vertical and part horizontal. And then we're going to apply constant velocity equations to the horizontal part and accelerated motion equations to the vertical part to find out things like how high it went, its maximum range, the x displacement, the time in the air, and variables like that. You must break this down into its x and y components. In other words, you can think of the 12.5 as being partly a horizontal velocity, and I will call that Vx, and partly a vertical velocity, and I'll call that Vy. And I'm just going to clean that drawing up a hair because I don't really like how it looks. Okay, so a moment ago we looked at right angle trigonometry and sine, cosine, tangent, and we showed how you can solve for a side if you know another side and an angle. Now, in the case of the horizontal velocity, which I would like to calculate now, we know that this is the adjacent side to this angle. This is the hypotenuse, and we know it. So because adjacent and SOHCAHTOA, because it is the adjacent and the hypotenuse that we know something about, or we want the adjacent and we know the hypotenuse, for the x component, we're going to use cosine. The cosine of any angle is the adjacent over the hypotenuse. But in this triangle, the adjacent side is Vx. That's what we're looking for. And the hypotenuse has a value of 12.5 meters per second. And we know the angle is 40.5 degrees. So we can take the cosine of 40.5 degrees, which is just a number. You can calculate the value of cosine 40.5 quickly with a calculator. But we can solve this for Vx. And when we do, we multiply both sides by the denominator, and we get Vx equals 12.5 meters per second times, and I'm going to put the cosine inside the parentheses with the angle. It does not matter. I just kind of like that better than that. At any rate, we can calculate that. And when we do, we get a value of 9.505. So the x component, or the part of this 12.5 that's solely or completely sideways, is 9.505. do that calculation and make sure that you agree that that is the value and that you're able to get that value the next time you have to do a problem like this for homework. Now the y component is this purple, and I'd like to calculate it. Now what side is that relative to the angle that we know? Well, it's across the street. It's the opposite, and we know the hypotenuse, so we're going to use sine to set that up and solve that. We have the sine of any angle, in this case 40.5 degrees, equals the opposite over the hypotenuse. But the opposite side is what we want. And the hypotenuse is known to us to be 12.5. So we can solve this for Vy by multiplying again, like we did here, get rid of the denominator, and multiply by 12.5 meters per second. So the y component of the velocity, the part of this 12.5 that is purely up and down vertical, is going to be 12.5, the hypotenuse, times the sine of the angle. And when we put that in our calculators, we get 8.118. Why did we do this? Why did we break the 12.5 into its x and y components? Now, if I'm reporting these, I might round them off to 3 sig figs because the angle and the hypotenuse velocity were known to 3 sig figs. But I'm just going to leave these as 9.505 for now and 8.11. So why did we do that? Why did we break it down? Sometimes physics teachers say that's breaking the vector down into its x and y components. But why did we do that? Well, the first question that we're asked to find after we're asked to find the two components, which we just did, is we're asked how long is the football in the air? So we want to know time of flight, total time of flight. But it turns out that we can't use this velocity to do that because it's partly vertical and partly horizontal. In fact, 8.118 of it is vertical and 9.505 of it is horizontal. But we can't use the 12.5 ever for finding things like the time and the height. So I'm going to ask you, which of these two velocities do you think gets it up off the ground? Does the horizontal one acting to the right get it off the ground? Does the vertical one pointing up get it off the ground? I hope your response is the vertical one that's acting up is what's going to get it off the ground. And in that direction, we have vertical variables, 5 of them, you may recall. We have initial vertical velocity, final vertical velocity, time, acceleration, and displacement, which is vertical displacement. Now, you're probably comfortable just putting 9.8 meters per second squared as our acceleration. Some of you probably want to put 0 in for a velocity. But we want the whole time of flight. And when it leaves the ground, this is its initial vertical velocity. Now, some of you might wish that I'd called it VOY to begin with, and you may do that. But I think of them as just two components, x and y, and so I didn't specify that it's the initial vertical velocity, but it is. Now, what's the final vertical velocity? Well, there's a cool little two-dimensional graphic that we have provided you on the last page of the notes for this chapter. And I would ask you just to take a moment and pay attention to this second drawing that's on the bottom. Look at it carefully. You have this paper in your packet. The velocity of the football at the instant that it comes to strike the ground and just barely does not strike the ground is actually, believe it or not, 12.5 meters per second. in the absence of air resistance, there's symmetry to this. But again, this 12.5 meters per second that's acting down at an angle can be thought of as having a horizontal component, Vx, and a vertical component, Vy. And just like what you throw up at 10 meters per second hits your hand coming down at negative 10 meters per second, what goes up at positive 8.118 comes down at negative 8.118. Have a look at that graphic and see that the vector lengths, that is true and that makes sense to you. Now, hold on, we have three numbers and a question mark, then we can call the fifth variable not applicable. Now, you may recall that when when vertical displacement is not applicable, the appropriate formula is the first equation. Final y velocity equals initial y velocity plus a times t. Solving for t, we get t equals final vertical velocity minus initial. I subtracted that. And then I divided by a to get time by itself. So this is our working equation for this part where we're going to find time. So let's plug in our values. Negative 8.118 meters per second minus a positive 8.118 meters per second over negative 9.8 meters per second squared. Now this is really like adding the number up twice. It's just negative 8 plus negative 8, which is negative 16.2 something. The time you would get is 1.656. Now, really quickly, some of you might have been more comfortable making one of these 0 because you're just used to that. You're used to a velocity often being 0. Now you could ask, is there any place along this flight that the vertical velocity is 0? Any place. Starts out at a positive 8.118. It comes down going negative 8.118. But yes, I hope some of you were saying at the top, its vertical velocity is 0. It still has 9.505 of horizontal at that moment, but its vertical velocity is 0. So you could put in 0 for your final velocity, but then you would only get the time from here to this dotted line I just drew. So what would you have to do with that time to get the whole time? Of course, you would double that, right? So that will work too, but I like to stick with the simple whole problem in one step. The third question we're asked is how far away is the receiver when she or he catches the ball? So if someone's going to try to catch that ball, how far away are they from the location that we have thrown it from? Well, that is the red brackets that I've put up here. What do we call that kind of displacement? One that is horizontal. Yes, we call it x. So now we're looking for x. And in the horizontal direction, there's no acceleration due to gravity. So we only have the simple equation v equals x over t. Often, lately, I've been saying vx equals x over t, because that's more specific and certainly true. Well, if there's only three variables, then let's write them down. X, Vx, and t. Now we want x. Do we know Vx? Yeah, in fact, that's why we had to break the 12.5 in the first place into x and y components. We found that it was 9.505 meters per second. That's how much of the football's velocity was truly sideways. And time, well, fortunately, we just solved for that. We got 1.656 seconds when we made our purple list and used the vertical equation. Let's take this equation, that is the horizontal motion equation, constant velocity, and we'll solve it for x. And when we do, we get x equals Vx times t. So the horizontal displacement x is Vx times t, which is going to be equal to 9.505 meters per second times the 1.656 seconds that we calculated with our vertical list. And the answer comes out 15.747. Again, I hope that you have been checking with your calculator. Part of why this is on a video that you can access on YouTube is so you can pause it and do the calculations and see how you're doing. That's what I would do if I were you. We got one last question, and it is, what is the maximum height that the football soars to? How high is its position off the ground at its highest point? We're going to make a vertical list for that because it's a vertical thing, okay? Height is a vertical quantity. And relative to the ground, we call that height often a displacement. It's a vertical displacement, y. So let's go ahead and question mark up our y. Of course, gravity is what keeps it from going forever and eventually stopping and coming back down. We could use half the time and plug in half the 1.656 seconds. But I'm gonna, for the moment, I'm not gonna use time. I'm actually gonna treat that as if I don't know it. And I challenge you to do it both ways. Use that half time and see if you dropped it from there for half the time, do you get the same answer I'm about to get? Now, I need a initial vertical and a final vertical velocity. I know the initial vertical velocity was 8.112. That's a fact, that's how we started out this problem. The final y velocity, do not put in negative 8.118. If you do, you actually get zero displacement, 0 meters, because where is it when it has a vertical velocity of negative 8.118? Well, it's right here. That's when it has a vertical velocity of negative 8.118. And so if you put in negative 8.118, you'll get the truth. You put the truth in, you get the truth out, but that's not the truth. The truth about the final velocity here is that it's 0. Like it is, at that moment that it's at the tip top, its highest point, which is what we're looking for, it's neither going up nor down any longer. It's on its way. It's about to change from going up to going down. And at that moment, its vertical velocity is 0. So if we take the equation on our toolkit that does not include time, it's the fourth equation. It's final vertical velocity squared equals initial vertical velocity squared plus 2 times a times the vertical displacement. Now, many of you want to cross that out right away and make it 0 because it is. But having 0 on one side can make the algebra more difficult for a lot of people, including me. So let me cross it out after I solve for y. I subtract this from both sides and get vy squared minus v naught y squared equals 2ay. Now I divide by 2a, and when I do, I get y equals this. So let's go ahead and do that. As I said, now's a good time to cross this out. It's 0. Don't forget, we had an issue on the last quiz. This negative is external to the problem. You square this number, then you make it negative. So negative v naught y squared, 8.118 meters per second squared, over 2 times negative 9.8. Many of you realize that these two negatives reconcile each other and go away, but that's what you want because the vertical height relative to 0, the ground, should be positive. When you perform this calculation, you get y equals 3.3624. And I will round this off to 3 sig figs before I box it up. So there we go. There is the projectile problem. In quick review, first thing, draw a picture. It's always a good idea. You must break this velocity that acts on the hypotenuse. You must break it down into its x and y components. We use sine and cosine for that. Once you've done that, use the vertical velocity for all the vertical issues, time in the air, height that it reaches, that kind of thing. And use the horizontal velocity for things that are horizontal in nature, like how far did it go when it was at the same height that it was launched at. Hope that was useful. I will also link to Canvas a Khan Academy that does this exact same thing. Again, other teachers explain things slightly differently, but I think it's useful for you to have both resources. Thank you for watching.